Hi YouTube, welcome to the MA Academy tutorial series. In this tutorial, I'll show you guys how to create a basic linked list in C++. Now this tutorial, I'll just cover the basics, a very simple way of creating a linked list. However, this is not the most efficient way of creating a linked list. The only reason I'm creating this linked list is so that you guys could understand how linked lists work and how they are created. Now in the next few tutorials, I will add more functionality to it. So for this one, it's just to show you guys and explain to you guys how linked lists work and how they are created, which parts of memory they take, how do we use pointers, how they are linked to each other, etc. So this is a very basic example. So the first thing for this tutorial that we're going to be doing is let's create a structure. So let's say struct and let's call it node. Now next, this structure I'm giving a name of node. You can give it whatever you want. Now next, I want to give it a data port, so I'm saying int data, and then I'm creating a pointer that will point to the next structure. So it's going to be of type struct node, and it's going to be called next. So in here, this is the structure that I'm creating. It has a data port and it has a pointer that will point to the next node. Now this is just what I'm using one data element in here, or one data type int. However, if you want to use more data types, you can do that as well. So you can also say something like float or double or string, whatever you want. So it doesn't matter for this tutorial. Just to keep things simple, not simple to keep things single, not sorry. Wow, I'm making this mistake again. Not single, to keep things simple. I'm just using data. So in here, however, if you want, let's say you want to create a structure for a student, you want their ID, name, grades, GPA, etc. Or if you want to create a structure for the movies, or songs, or whatever, so you can have more than one data element or more than one data types. So you don't have to have only one. You can add more if you want. Next, what we do is, let me delete this one in here. So this is our structure created. Next, what we do is we create pointers. So it's going to be of type struct node, and let's call it 1, and let's quickly create two other pointers. So let's call them 2, and let's call this one 3. So in here we have 3 pointers, and these 3 pointers have been created, and currently they are pointing to null. So in here we are not using it for anything, we are just pointing to null. So what does it mean? So in here, let me open this diagram in here. So currently what we do is, whenever you are creating a pointer, this pointer is created in the stack section of the memory of your program. Now these pointers are used to access elements or data in the heap section of your memory. So if you want to create data in the heap section of memory, you can access it using pointers. So when you're using linked list, you create these data elements or these nodes inside the heap section of your memory. So in order to access them, you need pointers. So currently, ignore this heap part. For now being, let's just concentrate on the stack section. So currently, with this piece of code, we just created these 3 pointers of type struct node. Next, what we do is we allocate memory, and in the heap section, and that these pointers, we want them to point to those areas of memory. So what we need next is we need to create these nodes in here. So in here, we haven't created them yet. So we have to create these nodes in here. Then what we want is, we want these pointers to point to it. So next in here, so we call one of them 1. So 1 is equal to a new node. So this is how you create a new node in C++. It was kind of different in C. This is a simple way of doing it in C++. And C, you had to use the malloc function and specify the size of it. However, in here you just type in new, and then followed by the name of the structure. So in here you can see that we have created 3 nodes. So what does it mean? Let's look at this in here. So this 3 lines of code that we did, it created these 3 nodes in the heap section of the memory. However, right now they don't hold these values of 22, 19, or 15. For now, these just have these sections of memory in the heap section, or these areas. These nodes are currently, these 3 nodes have been created in the heap section of the memory. However, we haven't inserted anything in these 3 nodes yet. So these, you can see that in here, 1 is pointing to this node, 2 is pointing to this node, and 3 is pointing to this node. So you can see that we have created 3 pointers, and these 3 pointers, they point to these 3 addresses. Next, what we do, we want to put data in it. We want to put these numbers inside these nodes. So how do we do that? So we can say that we run data, and we can say one data is equal to, for the first one, let's give it a value of 15. For the second one, data, let's give it a value of 22, and for the third one, let's give them a value of 19. So what does it mean? So these 3 lines of code, so we are saying whatever this pointers are pointing to. So 1 is pointing to this node, 2 is pointing to this node, and 3 is pointing to this node. So we are saying put this value 15 to the data section of this node. So this is the first. You can see that this structure that we created, it has 2 parts, right, or 2 sections. First is a data, which takes an integer, and the second one is a pointer to the next node. So we are saying the first one is data, so it takes an integer. We are saying take this integer 15 and put it into the first part of this node. So this is what the first one does. So whatever area of memory that this one pointer that you have created is pointing to, take this 15 and insert it into the data section of it. So this is the data section of it, and it takes an integer. This is where we can see that it takes an integer. So this assigns 15 to the first one. Next, we are saying assign 22 to this second one, and then we are saying 3 data. So whatever the 3 pointer, so in here you can see that this 3 pointer is pointing to this in here, to this node in here, and we are saying take 19 and put it in the data element of it, or in the first section of it. So you can see that these 3 values have gotten these 3 values get placed. Now the thing about linked list is that the good thing about linked list is that they point to themselves. They have the ability to point to themselves. So in here you can see that we have given the second one as a struct node next. So this is a pointer. What is it pointing to? It's pointing to a struct node. So this structure is of a struct node. So what it means this is a pointer that points to itself, to a structure, or to a structure of type node. So previously, if you are familiar with things like pointers and C and C++, they point to a data type. You have to specify whether you're pointing to an integer or a character data type, etc. So in here we are saying it's pointing to a node. So this section, this second part of it, it takes an address. So we know that the pointers, they take an address. So the second section, or the second part of this node in here, it should contain an address, right? An address of what? An address to the next element, or to the second node in here. So in here, the second node is this 22 in here. So we want this section of it, it should hold the address of 22. And the second section of this node in here should point to the third node. And the last node, this address, or the pointer section of it, contains the value null. What do we mean by null? It means that it's not pointing to any address. So when you're creating a linked list, how do you know that this is the end of the linked list? The only way you can know is when it's pointing to null. It means it's not pointing to anything. This is the end of the linked list, and the linked list is finished. So 15 is pointing to 22, and 22 is pointing to 19. So we have to give the address of 22 to this first node, and we have to give the address of 19 to the second node, and we have to put null into this third node. How do we do that? So again, we do the same thing. So we are saying 1, this time you are saying not data next. So 1's next should point to 2, 2's next should point to 3, and 3's next should point to null. So what does it mean? So we are saying this pointer, whatever is pointing to, the next section of it should point to 2. So in here, if I open this again, so you can see that this first one in here, we are saying that the first time you said the data section should contain 15. So you can see that the data section is containing 15. However, the next section is a pointer to the next. So it's pointing to another node. So in here, we are saying the next should take 2. So 2, what? It's the address of 2, right? So it takes the value of this second one in here, and it puts it in this section, the second part of this node in here, and the second section of this node. So now the second one points to the two nodes, to the second node. Then we say 2 next, and it's equal to 3. So what that means, it means take the address of 3 and put it inside the next section of the node called 2. So 2 is pointing to this node. It has 2 parts. The first one is holding this integer, and the second one is holding the address of the third one. So this address is now this section in here, it contains the address of the third node. Third node, as we said, should contain null, because we want the last element in a linked list, or we want the last node in a linked list to point to nothing, to point to null. So in here we are saying tree next, and then it should point to null. So the first one was pointing to the second one was pointing to the third one, and third point is pointing to null. It means it's not pointing to anything. So in here you can see that the this one, first one, it's this red line in here, it's pointing to 2. 2 is pointing to the third element in this linked list, and this one has null. It means this is the end of the linked list, and the linked list has finished or has reached the end of itself. Next, what we can do is we can print the values of it, right? So let me show you another diagram that I have created in here, this chart in here. So in here, this is the linked list. So you can see that we have 3 nodes in here in this linked list. So this is 15, 22, and 19. So in here, when we create pointers, first we create these 3 pointers, right? We say extract node 1, 2, 3. So when we create pointers, pointers also have addresses, right? So this is the first pointer, second pointer, and third pointer. They have their own addresses. So the first one has the address of 0x3c0, and the second one has the address of 0x442, and the third one has the address of 390. So they have their own addresses. However, for now being, they're not pointing to anything. Next, we are saying that the one, when we are creating a new node, so this creates this new node or new chunk of memory is pointing to this new chunk of memory, and it's pointing to that address. So in here we are saying 1, 2, and 3. So if I open this, the first part of this code, as we said, creates these pointers. The second one, we are saying 1 is equal to what? New node. So it creates a new node. So let's say it created this node, and you are saying 1 is equal to that. So this node that gets created, it gets created inside the memory, right? And this has an address. So 1 will point to that address. The same goes for 2. 2 will point to the second node, and 3. So this, when we say new node, it creates or it allocates a section of the memory for this node in here that we are going to create. And this node has 2 elements. One is the data of integer type and a pointer to the next node. So first time it creates that, second time it creates that, and the third time it creates these nodes. And we reference these nodes by this pointer. So one is pointing, the first pointer is pointing to this node, the second pointer is pointing to this node, and the last pointer is pointing to the third node. The same thing in here, we can see that. So these nodes in memory, they have addresses, right? So the first node, let's say it gets the address of 0x110. By the way, when we run this program, when we do debug of it, we can see that the addresses are very long. However, for simplicity's sake, I'm using very short names. The second node in here gets its address of 0x126, and the last node gets the address of 0x124. So in here, you can see that the first one, we gave it the number 15. So we assigned 15, 22, and 19. So you can see that the first sections of it, they are data and they hold these 3 numbers. However, next, what we did was we said the next part of it should contain the address of 2. So in here, you can see that it holds 0x126. So what is this 0x126? It is the address of the second node. So in here, you can see that the second node resides in this part of the memory, which has the address of 0x126. So this is pointing to the second node. And the second node also has an address. It's 0x134. So what is it pointing to? It's pointing to the third node. So we can see that the third node has this address of 0x134. So these all nodes in the memory, they are pointing to each other. And the last node, as we said, it does not point to anything. It holds the value of null. It means that we have reached the end of the linked list, and this is it. So this is how these values in here, this code means. So the first, we create these pointers. Second section in here, we are pointing them to these nodes. So these nodes get created inside the heap section of the memory, and these pointers that we created earlier, these are in the stack section. So these point to this one. Next, the third part, we said 1 data, 2 data, and 3 data is equal to 15, 22, 19. So they assign these 3 values to it: 15, 22, and 19. And last, the next part of these 2, so the first, we say the next part of 1 points to 2. So we can see that this is the next part, right? It points to 2. So this is the address of 2. Then we say the next part of 2 points to 3. So the next part of 2 is this address, and it points to the address of third one. And last, we say 3 next. So the next part of this node called 3, it's pointing to null. So it's the end of the linked list, so it's not pointing to anything. Next, let's print its values. So how do we do that? Let's say cout, and then let's say 1 data, and let's do an inline. Let's copy and paste it quickly. For this one, let's say 2 and 3. So when we run it in here, so you can see that we get print, these values get printed. First there is 15, then there is 22, and then there is 19. So these 3 values get created. Now let's do a quick debug of it so that we could better understand this code, what is happening. So let's set a breakpoint in here. Let me make this window larger and let's run it. So when we run it in here, the first time you can see that this pointer, it's a pointer of 1. However, we haven't executed this line yet, so it's pointing to some random address. So when we go to debug and we say step into, so this line gets executed, right? Now we have this variable, this pointer 1. It's not pointing to anything. Then the second one gets created, and then the third one gets created, and they will all point to null. So the first one got created, it's not pointing to anything. Null, it's first it was pointing to something, then when we executed this line, it wasn't pointing, and now it's saying pointing to null. So this 2 now gets created, and so right now it's saying null, but as soon as we execute this line, we say a step into, it will also say a step into none. But since it already says it won't make much of a difference, or it won't show us. So you can see that these 3 lines they get executed, and now you can see that we have 3 pointers and they are not pointing to anything. So you can see that there is a data section to it, since it's a pointer to a data structure, and the data structure has 2 elements in it, the data and the pointer to the next element, right, and the linked list. So we can see that there is a data and a next part. However, it's also set to null because we don't have anything yet. So the same goes with 3D nodes. Next, we say that 1 is equal to new node. So this line of code, it creates a chunk of memory, or it allocates a chunk of memory of the size node, and it points, and this one pointer points to it. So as soon as we say step into execute this line, you can see that the 1 in here, the pointer called 1 is pointing to this section in memory, which is AD0. So when I hover my mouse over this, you can see that it again gives me the same value of AD0. So you can see that this address in here is the same as when I hover my mouse over 1. So it means that this one pointer is pointing to this address. So if we go to this diagram in here, so first we created these 3 pointers, and now this one pointer is pointing to an area in memory, right? This 15. This is a chunk of memory. However, for now being, it doesn't hold the value anything yet because we haven't assigned it, but right now it's pointing to it. So what is the address of that memory? So right now we saw that it's pointing to this 0x158AD0. However, I will just say the last 3 digits in here. It's easier, or sorry, the last 3 hexadecimal numbers in here. So that way it will be easier. So the first one points to this section of the memory. And then next, if I say step into, you can see that the second one points to another area of memory. And when I say step into again, the third one again points to another area in memory. So what does it mean? It means that these 3 pointers, these 3 nodes have been created in the heap section, and now these pointers are pointing to it. So what do we do next? Next, we have to assign data to it. So right now, if I expand this, you can see that the data is empty, and the next pointer is pointing to some random address. I'm not sure it's even valid because it's very long in here. This number is in here. I'm not sure it's pointing to an address. It's a section of memory. So the same goes with 2. The data is 0. Next, it's nothing. And the last one, data is 0, and it's pointing to nothing. So let's execute this line in here, and let's say step into. So you can see that now it says 1 of the data is 15. So when we go to 1, previously this one was 0. Now S15. Why? Because we say the data section of this one pointer should contain 15. So whatever this one is pointing to, the data section of it should hold 15. So in here, next we execute the second line. So let's go again to, you can see that data is 0, right? However, as soon as we execute this line, so let me minimize this second one, so the first one. So this data is currently 0. So when I say step into, it executes this 22. So we can see that this data section now says 22. The same goes for the third one. So the third one currently it has 0 in it. So let's run it, sorry, not run it, debug step into. So now you can see that it holds 19 into it. So now when I expand these 3 pointers in here, the data section of the first one says 15, the second one says 22, and the last one says 19. So however, you can see that the next pointer, it points to some number which is not the address memory. So we want it to do that, to point to the next. So in here, this line, you can see that it says that the next pointer of 1 should point to 2, and 2 should point to 3, and 3 should point to null. So in here, let's minimize these two. So right now you can see this is some random number. So as soon as we execute this line, so I say step into, so now this one, it points to the second one. So it is, you can see that 790. So in here, note this, these two numbers, these two addresses are the same. Why is it the same? Because the first one is pointing to the second one, right? So in here we say one's next should point to 2. So 2 has the address of 790. So we are saying the next section of it should point to 790. So this is the address of second one in here. That's how it works. The first pointer is pointing to the second one. So if I open not this one in here, so you can see that the first the first node, it points to the second node, and the second node points to the third node. So this address and this address, they are the same, right? Because this one is pointing to this one. The same goes in here. The first one is pointing to the address of the second one. So right now we can see that the next is same as this next address is the address of the second pointer, second node in the memory. Next, if I expand pointer number 2, you can see that this is again some random number. However, the second one should point to the third one, right? And what's the address of the third one? D90. So as soon as we execute this line, we say and step into. So now you can see that D90. So this is the address of the third one. So D90, this is the pointer, the address of the third node. So we can see that the next section of the second pointer is pointing to the third node. Again, the last one, we said the last one should point to null. So right now, if we see 3 currently, it points to some random address or random number in here. So as soon as we say step into, you can see that right now this 3 in here, it says null. So it means that it's not pointing to anything. Next, what we do is we print its value. So as soon as we execute this line in here, it should give us the value of the first one, which I think was 15. So yes, you can see that it executes, it shows us 15. Next, we are doing a console output of the second one, which I think was 22. Yes, it is 22. And let's do one more, step into, and it shows the last one, the value of the last one, which was 19. So this is how the linked list works. Now, so this tutorial is getting kind of long, but I think we have a few more minutes. If we, let me show you guys a couple of more things in here. So let me first delete this in here, this breakpoint, and run it. Let's stop this. So this is working good. Next, let's just do one more thing in here. So if, let's say what we want to do is we want to also see the addresses of these things. So right now we are only seeing the data that it's pointing to, right? So we want to see the addresses as well. So how do we do that? So if I say cout 1 next and I say NL, so it will show me the address of it. So now if I do the same thing, it's 2 and next, and the same for the last one in here, cout 3 and next and NL. So if I say run, so in here you can see that it gives me the addresses of it as well. So the first one has data of 15 and it's pointing to 30. So 30 is the address of 830 is the second node, and the second node has, then we say the third line prints 22, this one in here, and then it points to the third node. Then this is the address of the third node. In here the data section gives us the value of 19, and the last one it says next. So we said next is equal to null. So in here, let me open this again. So we saw that the last pointer's next value should contain null. So how do we represent null in computers? It's 0x0. So it means when we execute this line in here, this one, you can see that it gives us 0x0 because the next section of the last one is pointing to null. And I have said many times, the null, when we see the null, a null in the linked list, it means that this is the last element in the linked list. Now I think there's one more thing that we can do. I'm not sure, just 1 second. So we can also print the values of the nodes or the addresses of the nodes. So let me do this quickly in here. I'm not sure we have enough. Yes, I think we can squeeze a couple more minutes. So let's just run it again. Okay. So one more, if we do it, So yeah, we don't need that one more. So in here, let's run it again. So what are you doing in here? The first thing we say cout1. So what does it do? It gives us the address of the value on which this one pointer is pointing to. So it's pointing to this address, which is what? Let me maximize this window. So this is this address in here, 48B0. So we can say that this is pointing to 7B0. This is the address of the first node, and it has two parts, a one part and the second part. So the first part is the data, and the second part is the value of the next node. So in here we can see that 15 was the contents of the first element, and then it's pointing to another element, right, to another node. Next we are saying show me the address of the second node. So you can see that this address and this address is the same. Why? Because this is the second address, this is the second node, and as we said in here, the second node in here, the address of it should be pointed to by the next section of the first node. So in here you can see that this is 0x126, this is 0x126. So they are first pointing to each other, right? Sorry, not to each other. The first one is pointing to the second one. So in here you can see that 2 has this address, and one's next. This one in here is also pointing to this address. This is how linked lists work. The first one is pointing to the second one is pointing to the third one, and so on and so forth until we reach the last element in the linked list, which will point to null. Next, this is the data section and the next section. So the data section is 22, and the next section again has this address of 5C0. So it should be the address of the third node. So you can see that this line in here, when we execute it, it gives us this address. So these two addresses are the same, because as I said again, in here the second element, its next should point to the address of the third element, which is 0x134 in this example. So in here you can see that when we say that 2's next is pointing to this address of 5C0, and when we say like show me the address of the third node, and you can see that it's also 5C0. So these two same addresses, it means that the second one is pointing to the third one. And then we print out the data, which is 19, and at last the last element of the node should have the value of null, which we saw in here. This is how we know that the linked list is ending. So in here you can see that this 0x0, this is null. This is how we know that the linked list has ended. So this is it for this one, guys. I know it's been a long tutorial, but I just wanted to cover it in detail so that you guys could understand it very well. So this is it for this one, guys. If you have any questions, suggestions, or recommendations, feel free to put it in the comment section below. And if you found this tutorial useful, make sure to share it with your friends. And in the next couple of tutorials, I will add more functionality to it. I will make this code more efficient. So if you want to learn more, make sure to watch the next couple of tutorials as well. And I'll see you guys in the next one.